way and then back, I'm on the negative side of my starting point, so it's negative there. And what about all those?
Positive.
Just note that in this case, at all the zeros, I am switching from positive to negative or vice versa. Not always the case, which we might see in acceleration. Let's see, so this is positive. All right, velocity. Where is the velocity equal to 0? Nope. At A, if it were 0, it would not go up the ramp.
Either of.
B,
I heard B.
G, J.
And J. J is that turnaround point. That's when we end the problem, but it stops temporarily. If we kept going, it would come back down the ramp. All right. So from up until B, positive velocity or negative velocity?
Negative.
Because I'm going that way. Now, I didn't state this explicitly. I am dealing with just the horizontal motion. We could do it for vertical as well, and the answers would be slightly different, depending upon which way I made positive or negative, but I am only considering just the horizontal piece of it. All right, what about between B and G? Yeah, I'm moving to the right. And between G and J?
Negative.
All right, we'll do a dramatic pause here for questions before we tackle the tough one. And if you're not quite sure how to ask the question, just try it any old way and we'll see what we can get, what we can do with it. All right, acceleration. Where's acceleration equal to 0?
E to F.
Pardon?
E to F.
No, the acceleration will not be 0 there. I've now realized there is a mistake here. Let me see how easily I can just correct this without having to change anything else. This should all be fine. I am going to change this. I'm going to make this have friction. And make F and H the box. Say F, the box is, it's the last moment when the box is completely on level surface. And H would be first moment, box is completely on level surface.
Question.
Yes, Alan.
So the acceleration is 0 when the velocity is constant.
Correct.
But the velocity isn't the velocity not constant throughout the problem?
Well, with that change, the velocity will be constant during a certain segment.
Oh, okay. Well,
All right, so asking the question I did before, and who gave me the answer before? So when is the acceleration 0?
J.
E to F.
Oh, sorry, Matthew, question?
No.
Answer, all right? Yeah, in this region right here.
Yeah, Rob.
Yeah, this region right here, because I took friction away, there's nothing that's gonna speed up or slow down the acceleration, or speed up or slow down the box.
Would it also be J since it stops moving?
Oh, the acceleration is not 0 there, because remember, it's stopping there for an instant. We just stopped the problem there, but the box would come back down. All right, so E, box first touches level surface. Oh, with that change, I also have to change this. All right, box first completely touches level surface. Because if it's first touches the level surface and not completely, then there's still an acceleration because part of it is still being forced downwards. So I need to have this of when it's completely on the level surface. All right, so E, that's 0, that's 0, that is 0. All right. If those are the only zeros, well, then I'm going to be changing here. So what about over here? Positive or negative acceleration?
Negative. The velocity is going to the left. So since which is negative.
You have just ignored what you had said earlier.
Positive.
Why?
It's speeding up.
Yeah.
Positive direction.
The entire time?
It stops at E. Or
It stops at B.
B for what? Okay.
From A to B, what's it doing?
Oh, A to B, I wasn't there.
Oh.
Positive, right?
It's still positive, yeah.
Yeah.
From A to B, it's positive because it's slowing, one way of looking at it, it's slowing down, and if it's slowing down, they're opposite signs.
Yeah.
Or my velocity is going from something, some negative value, looking at only the horizontal component, some negative value to 0, that is a positive change. So it's gonna be positive there. And then it starts speeding up on the way back, so they'll be the same signs. And these will also be positive.
That's what I was saying.
Okay. And then over here on G, oh, there's another 0 region.
Oh, F with H to I.
Yeah. Okay. And then from between F and H, there's negative.
Speeding.
Why?
Of the friction and slowing down.
So
It's the same sign as the velocity because it's speeding back up, down the ramp.
speeding back up, down the ramp. So it's slowing down going up the ramp and speeding up going down the ramp. So as it's going up the ramp, it's definitely slowing down. So
I jumped the gun again.
It'll be
So
negative.
from F to G, slowing down, so that would be negative. From G to H, it's speeding up, so it'd be the same sign as velocity, and then turnaround point, it's just gonna be negative. And then from I to J,
Positive.
all right, questions about this before we take a look at it a different way? Now let's take a look at it a different way. All right, I'm just gonna make numbers up here, and I'm only gonna be looking at just the horizontal motion. So let's say it starts out going 10 meters per second, negative 10 meters per second. At this point it's 0, at this point it's 10 meters per second. Here, say 20 meters per second. Going this way, this is at time D, at time, there we go. At A, it's 10, negative 10, B, it's 0, times C, it's positive 10, positive 20 at D. E, let's say 25 meters per second, because it's speeding up, it maintains that velocity, 25, and then it starts slowing down at 0 here. At H, it's going back the other direction, not fast as it was going before, so let's just say negative 15 meters per second. Because of friction, you're losing something. At this point, negative 15 meters per second, at this point, 0 meters per second. Now, later on, it should be able to give you enough information so you can actually figure out what the values are. But for right now, just so long as it's when it's moving to the left, it's negative, when it's moving to the right, it's positive, and it's 0 at the points that we already said. Now, from A to B, we go from negative 10 to 0. What is the change?
I say again.
When I go from negative 10 meters per second to 0 meters per second, what is my change in velocity?
10 meters per second.
meters.
I heard something over there?
Positive 10?
Yep. When I go from 0 to positive 10, what is my change?
Plus,
Ten.
positive 10 meters per second.
Still positive 10. When I go from 10 to 20, I'm there at D. Go from 10 to 20, what's my change?
10, positive 10.
Positive 10 meters.
From 20 to 25,
Positive 5.
from 25 to 25,
0.
0.
from 25 to 0,
Negative
25,
25.
positive,
from 0 to negative 15,
plus 50.
Plus 10.
Minus 15.
final minus initial. Change is always final, it's where you end up relative to where you started. Negative 15 minus 0, negative 15. That's negative 15.
Yeah.
Negative 15 to negative 15,
0.
negative 15 to 0.
Plus 50.
So between A and B, I have a positive change in velocity, I have a positive acceleration. From C to D, I have a positive change, it should be positive over there. Over here, from F to G to H, I have negative changes. My acceleration is negative in that region. So just a different way of looking at it. Since acceleration is positive, when the change in velocity is positive, negative, et cetera, et cetera. Questions? Wesley?
So why is from G to H negative? Is it like the acceleration? Why is the acceleration negative?
Right.
Is it because of the frictionless? Like,
I mean, there's still friction there, but
like the velocity's moving in the negative direction, right?
yes, and it's speeding up,
So,
same sign.
okay.
Change is always the final value minus the initial value. So my final velocity, so if I'm talking about G to H, my final velocity is negative 15. My initial velocity is 0. And then that's just negative 15. So another reason why it's negative. And from a force point of view, the net force is down the ramp. If friction were greater than the part of the weight acting down the ramp, chapter 4 stuff here, then it would not have, it would have stopped before then, or not even moved from here. Other questions? I assume, Wesley, your question was answered?
Yeah.
Okay. Other questions? One other thing that we can do on this is graphing. If I wanted you to do a graph of position time, velocity time, acceleration time, what does it look like?
Some nonsense.
A sketch of the graph. It's not precise, but just a sketch. Well, let's do it.
Look like that.
No.
We already have a big graph.
If it, well, we'll find out. It's not gonna look like that, but let's take it bit by bit. So we'll put A here, B, C, D, E, F, G, H, I, J. It's a crude sketch. It doesn't have to be perfect. What I am looking for is, one, do your answers here on the graph match what you wrote over there? Two, is it consistent with the next graph? If this is position versus time, the velocity versus time should be the slope of this. My acceleration should be the slope of my velocity graph. The other thing I look for is it a function? In other words, do you have the object in two different places at the exact same time? It should not be that way. Not till you get to quantum physics. And is it continuous and differentiable? And what I mean by differentiable is that the slope, you get the same slope coming at any point from both sides, which translates into, are there any sharp kinks? Sharp kinks in the graph, it's not differentiable. So it should be a smooth curve, whatever we get done with. It is an iterative process. So I would recommend not doing it in ink the first time unless you have erasable ink. So when doing it, I'm gonna look at it and I'm gonna figure out where's zero. So I know zero at E and I. So E and I. Okay, this part's what's marked down. I know it's negative to start with. It becomes positive and then negative again. So I'm just gonna do a crude drawing here. It doesn't quite go back as far as it initially started, and so the negative value here at the J shouldn't be as far negative as A was. As a matter of fact, I know B is farther away, so really, and at time A and time C, they should be in the same position, so there we go, slightly better. Velocity. I know my velocity is zero at B, G, and J. So B, G, and J. It starts out with negative velocity. It reaches its fastest point at time E. So E would be a peak there. And then it is constant from E to F. So draw that straight. And then it drops down quickly to G. And then in the negative direction, it becomes H, then it's constant, and then it goes to there. All I'm doing is, first off, matching what I have over there. Just double check. All right. And then I'll look at the slopes in just a second. Acceleration, I know it's zero from the E to F. And from H to I. It is positive up here. It is negative, it is positive at the end. So if nothing else, at least I'm consistent with what I've written over here. I did not do a graph of displacement versus time. What would displacement versus time look like? In regards, so it's similar to which one?
Position.
I think somebody just said it.
Position.
Yeah. So how would the displacement versus time graph look different from the position versus time?
It won't.
Oh, it will.
No, no, it starts at zero, right?
Ah, yeah. So the whole thing would just shift so that it starts at zero. That's the difference between the two. So if you can do this one, I'm hoping you can do the other one just by moving everything to the starting point of zero. All right, questions how we got this far before we start fine tuning? All right, I know that this is the slope of that. I have a negative slope. I have a negative velocity from A to B, so from A to B I should have a negative slope. Check. I have a positive velocity up until G, so I should have a positive slope from B to G. Check. G is zero, velocity is zero, so this should be that, it should be level there, that should be the flat line at D. J is zero, so this should be zero there, so this is gonna curve more like that, it's gonna flatten out as we get closer to J. All right, those are consistent. A, I know A is positive here, so my slope should be positive up until I get to E. So there's a positive slope there. F to, and then it's flat line. I have negative acceleration there, so I should have a negative slope here, okay? Zero, flat line, positive, and there should be a positive slope there, okay? That checks. Do I have any sharp points? Well, it looks like I kinda got one right here, so let's smooth that out a little bit. I think that's probably smooth enough, this is not. I know it, see, F is zero acceleration. Yeah. So it should curve off just after that. Just before that. Just after that. And the way I have this is that it's slowing down. In essence, we have it, except acceleration in this first region up to here is actually, that's a constant negative acceleration. Constant positive acceleration. So before D, this actually should be positive, and then it drops off. So, which means that this should be a straight line. Well, sometime between C and D. Which means between here and there, this should be a parabola. Slightly better. If I looked hard enough, I might find a couple other things. But that, in essence, is a sketch of the graphs. And none of them really look like